Today we are looking at one of the simplest water level sensors, a stainless steel float switch. It has only two wires and we can connect it directly to a digital input of an Arduino. Here you can already see the complete demonstration. The Arduino reads the switch state and prints the result in the serial monitor. There is no analog measurement, communication protocol or complicated library involved. The moving cylindrical part is the float. When the water level rises or falls, the float moves along the stainless steel shaft. Inside the float is a small permanent magnet, while a sealed reed switch is located inside the shaft. As the magnet moves past the reed switch, the electrical contact changes between open and closed. The Arduino sees this as a normal digital signal, either high or low. In this orientation, moving the float changes the contact state, and the result immediately appears in the serial monitor. Now let us look at the connection. Because this is simply a switch, it does not need a separate sensor power connection. The two wires are just the two ends of the internal reed contact. One sensor wire is connected to ground, the second wire is connected to Arduino digital pin 2. The input is configured using INPUT PULLUP, which enables the Arduino's internal pull-up resistor. With this configuration, an open switch produces a high input. When the switch closes, it connects the input to ground, so the Arduino reads low. This means the electrical logic is inverted compared with what a beginner might initially expect. The exact relationship between high and low and the actual water level depends on how the sensor is installed and on the orientation of the float. In this demonstration, the code interprets the open and closed states according to the selected mounting direction. This type of switch can be used for a tank full alarm, a low water warning, overflow protection or automatic pump control. It can also detect whether a container has reached one particular level.